In this video, I'm just going to solve one problem, and it's going to be solving a radical without using variables. So if you're looking for something with x squared or y to the fourth, you want to look at a different video. In this video, we're just going to simplify the square root of 19,440,000. And first, it would make sense to talk about what we actually mean by simplifying one of these things. A radical is simplified if the number inside of it, called the radicand, if this number right here is not divisible by any perfect squares. So if I find a perfect square that divides evenly into that number, I know I'm not finished. I have to keep on going. Now, the first thing that you should always do if you're trying to simplify a radical is to make sure that it's actually not a perfect square to begin with. So I'm just going to take this and plug it into a calculator, and I'm going to hit my square root button. If it's a nice square root, I don't actually have to do the process that I'm about to do. But in this case, I get this weird decimal here. And if you're hoping that it's going to start repeating itself after a while, let me save you the trouble. If you're starting out with an integer, any old integer, if it's not a perfect square, if the integer is not a perfect square, then the square root is going to be irrational. So it's never going to repeat. So that means that we have to do something else. So here's what I'm going to do to start out. I'm going to just write down my number that I started with. And then I'm going to look for any perfect squares that will divide evenly into this number. So I'm noticing that I'm going to have a perfect square that divides evenly into this because it ends in double zero. Whenever it ends in double zero, I know that this number is divisible by 100. 100 is a perfect square. You might also be able to tell that since it ends with 4 zeros, that it's divisible by 10,000, and since it ends in a 4 also, it's divisible by it's going to be divisible by an even larger perfect square. But we're going to start small. But the larger number that you can see dividing into it, the easier this thing is going to be to figure out. So let's start out with we're going to start out by taking our square root, and we're going to have 100 on the outside, or on the inside, but we're going to list it first. We're going to list our perfect square first, and then we have to list everything else that's along for the ride. So I ask myself, what times 100 will give me 19,440,000? And I just write whatever that number is. So I know that if I multiply these two numbers together, I will get 19,440,000. Okay, so we talked about something in class, a property in class where if I have two radicals with a product on the inside, I can change that into two different radicals. So if I start out with one big radical, I can change that into a radical times another radical. I can split up my my square roots. And the whole point of doing that is to get this square root of 100 by itself. So instead of having a square root, I don't want that square root anymore. I want to write this without a square root. So I'm just going to write 10. This is going to be 10 times that big square root. So already this looks a little bit simpler. The number's not as big. I have this nice number on the outside, but I'm still not done. I notice that I still have a double zero on the outside. So with that double zero, I know that it's still divisible by another 100. So I'm going to rewrite this as 100 because that's my perfect square. I'm always writing my perfect square first. 1944. And again, and I have to make sure that I'm keeping this 10 along for the ride. But again, I'm going to split up this square root because I just have multiplication. Whenever I just have multiplication or division, I can split up my square roots. As soon as I introduce addition or subtraction, that ruins the party for everybody, and I can't do this method anymore. Oh, I don't want to write a square root again. I want to write 10 instead again. So the square root of 100 is 10. That gives me another 10 right there. And then times this 1944. So it's getting a lot smaller pretty quickly. Now I have to look for another perfect square. And here's where divisibility rules are really helpful. I notice that the last two digits are divisible by the last two digits when I take it is 44. This is divisible by 4. Therefore, the entire number will be divisible by 4. This 1944 is divisible by 4. So what I'm going to do is I'm going to pull out a 4, and then I'm going to write whatever it's equal to. And it turns out to be 486. So if I divide 1944 by 4, I get 486. And again, I'm writing my perfect square first, and then I'm going to, again, split apart my radical into two different radicals, get 486 in one radical, and then square root of 4 in the other radical. And then, again, I don't write a square root. Instead, I'm just going to write whatever that square root is equal to. Square root of 4 is 2. And then I have this guy left over, 486, inside that radical. Now I'm going to keep on going. It might be tough to see what another number is that will come out of there evenly. But you might remember that if you add the digits, in this case 4 plus 8 is 12, plus 6 is 18. If the digits add up to something that is divisible by 9, then the number itself is divisible by 9. So that's going to help us. 9 is a perfect square. This adds up to 18. Therefore, 18 is divisible by 9. Therefore, I know 486 is divisible by 9. I'm going to pull out that 9. And if I divide this by 9, I would get, oops, lost my calculation. I would get 54. Now, I'm going to do the same thing again. I'm going to take, this is 10 times 10 times 2. So I've got the string of numbers, and at any point I could multiply all of these together, and that will help me simplify it. So I'm going to split apart this radical, 54, and then I take the square root of my perfect square inside that radical. So I take this square root, the square root of 9 right here, and I get 3 times the square root of 54. That's going to be equal to 10 times 10 times 2 times 3. I look for another perfect square root. 5 plus 4 is 9. 9 is divisible by 9, therefore 54 is divisible by 9. 9 times 6. I do the exact same thing again. I'm going to split apart my radical, square root of 9, square root of 6, and then I take the square root of that perfect square, okay, and now all I have to do is multiply all of these together. When I do that, I get 1800, but I've also got this square root of 6. There are no perfect squares that divide evenly into 6, so that's when I know I'm done. This is as simple as it gets. Now, this took us a lot of steps, so if you can see that you can pull out a larger number, then you should go ahead and do that. However, it's not always quicker to look for the larger number. It may be a really big number, and it may be really difficult to find. So if I'm taking, let me start again with this square root. The square root of 1944,000. Let's say that I call that the square root of 324,123,4 times 6. So I pull out this perfect square all at once, what's going to happen is when I split this apart, 324, 0, 0, 0, 0 times square root of 6, this will give me 1800 times the square root of 6. That was much faster, but I wouldn't count on anybody just looking at this number and figuring out that that's 6 times this huge square, perfect square right here. It's probably going to take several steps to break it down, but it's always done the exact same way. Let's take a look at what we did. We took this number, we looked for any perfect squares. We found a perfect square because we know our divisibility rules. This is divisible by 100. And then we wrote our perfect square first. I'm always writing my perfect square first. I wrote 100 first there. I wrote 100 first there. I wrote 4 first here. And then I wrote 9 first down here. And again, I wrote 9 first down here. So I always write my perfect square first, because when I break it up, everything ends up where it's supposed to. That way, if I would have lined it up the other way, then my 10 would have ended up after my radical. If I do it this way, then all of my numbers are going to line themselves up just like they did. I started out with a 10, and then another 10 added onto it, and then we tacked on we tacked on a 2, and then we tacked on a 3. Everything is lining itself up. I don't have to do any weird bookkeeping where I have to go back, I have to backtrack or anything like that. Everything is lined up so that all I have to do at the very end is just multiply all these numbers together and then just put this radical right next to it. So if you use this method, if you just follow those 3 steps, and again those 3 steps are find a perfect square, write it first, break up the radicals, and take the square root. If I do it over and over again, eventually I will end up with a simplified expression.